We are now going to look at some examples where we will be evaluating limits analytically that approach the vertical asymptote. Our first step is still going to be direct substitution, but we get a different result when we do that direct substitution. We get 2, or a number, over 0 instead. This tells us that we can't factor and cancel or do some other simplifying technique. So when direct substitution yields c over 0, where c is a constant, it tells us that the limit does not exist and it also tells us that the limit increases or decreases without bound. Now, what we want to check for is if both sides are increasing or both sides are decreasing. So we kind of treat it like a one-sided limit. We're going to do the limit from the left and the limit from the right and test that out. So a lot of this is thought process based, but what we want to think about here is what would happen if I had like 4.001, like if we were plugging that value in the table. Would we have 2 over a positive number or 2 over a negative number? If we're doing 4.001 minus 4, we're left with a 0.001. So we're left with something that's positive, which means that this is going to approach positive infinity. Technically, you don't have to write the positive in front of the infinity, but I'm just doing it to overemphasize it here. And then if we do the same thing and do limit from the left, 2 over x minus 4, you want to think 3.999. Same as if we were plugging in the table but not actually using the table. Well, if we plug in 3.999 minus 4, we're going to get a negative on the denominator. And the numerator is already positive, so that tells us we're getting negative infinity for that limit. Therefore, since those two limits are different, the limit as x approaches 4 of 2 over x minus 4 does not exist. So it doesn't increase or decrease without bound because the sides are different. Remember, for the positive infinity one, that's increasing without bound, and then for negative infinity, it is decreasing without bound. So if you're doing just the right side or just the left side, you can talk about that. But if you are doing both sides, they're different, so that limit does not exist. Let's take a look at one more example, how to think about this. So this one's actually very similar with a slight twist. Same thing, plug in the 4, you get the 2 over 0. Just like previously when we had to show the 0 over 0, always show, since it tells you what to do next. Because if you get 0 over 0, you know that a factoring technique or another technique of simplifying will work. Here you know that that doesn't work, so it tells you a different testing out technique. So let's do limit as x approaches 4 from the right. You kind of think about the same numbers, again thinking 4.001, 2 over something that's positive, squared is still going to be positive, so we definitely are getting positive infinity again. And then limit as x approaches 4 from the left, if we think 3.999, we're getting 2 over something that's negative but squared. And when we square something that's negative, we're still left with a positive result. So now since both of these are positive infinity, we can say that the limit as x approaches 4 of 2 over x minus 4 squared is also positive infinity or increases without bound. And that just means that both sides of the vertical asymptote are approaching that positive infinity value. Limit doesn't exist because you can't reach infinity, but it's telling us that if we were to look at this graph, both sides of our asymptote line, just erase that and make it into an asymptote. Here's my vertical asymptote. Both sides are going towards positive infinity, where on the previous example, one side was going up and one side was going down.